All right, today's notes are 8.2 parallelograms. So you already took notes yesterday on parallelograms, and we're going to break down those notes into examples and into theorems. Okay, so starting here, feel free to pause the video, write the notes, and then listen to what I say about them. And you don't need to do it all at the same time so that you better understand what's going on, okay? So the first thing is the definition of a parallelogram, which is a quadrilateral with both pairs of opposite sides parallel to each other, okay? To name a parallelogram, you use this symbol here. I would recommend practicing writing that symbol out because we will be drawing those shapes a lot, okay? So here's the example. In parallelogram ABCD over here, BC is parallel to AD, and AB is parallel to DC by definition. Okay, so go ahead and pause the video and then read that over and make sure you understand it. That this side and this side, top and the bottom, are parallel to each other, and then the two sides are also parallel to each other, and that's what makes it a parallelogram. All right, go ahead and copy down these theorems. These are theorems, properties of parallelograms. So we're putting the properties into theorems. So the first theorem is 8.3. If a quadrilateral is a parallelogram, then its opposite sides are congruent, okay? So we are going to write that in an abbreviation form. This abbreviation form is what you will write in your reasoning on your proofs. Let me say that again. This abbreviation form is what you need to write on your proofs in your reasoning section. Okay, so we're going to write out the abbreviation here, and it is written like this. Okay, opposite, you can shorten that to the word OPP. Sides of a parallelogram are, and then the congruent symbol. Okay, that's how you write it as an abbreviation. Okay, and the example here is, here's the picture, and our example is if JKLM is a parallelogram, then JK is congruent to ML, and JM is congruent to KL, and we're going to mark those on here. So this one is congruent to this one, and this one over here needs to be congruent to this one. If it's a parallelogram, then those are congruent to each other, okay? And then the second theorem, the next theorem is if a quadrilateral is a parallelogram, then its opposite angles are congruent, okay? So this is opposite angles now. So the abbreviation here is written opposite angles of a parallelogram are congruent. That's the congruent symbol. Okay? It's an equal sign with a squiggly above it. All right, so then the example here, here's the drawing, and we're going to write if, same thing, if JKLM is a parallelogram, then angle J is congruent to angle L, and angle K is congruent to angle M. And then we need to show that on the picture. So J is congruent to L with one arc, and K is congruent to M, and you'll put a double arc, that those two across from each other are congruent. All right, two more theorems here. Go ahead and write them down. 8.5, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, we'll talk about what that means. Remember, consecutive means next to each other, supplementary means add up to 180, so our abbreviation for this is going to be you can shorten the word consecutive to CONS, consecutive angles in a parallelogram are supplementary. You have to write the whole word supplementary out. So that abbreviation is what you'll write in your reasoning when you do proofs, okay? So the example here is if JKLM is a parallelogram, then x plus y equals 180. So we're looking at this parallelogram over here. X plus y, those are consecutive. Those are two angles next to each other. They add up to 180. Same over here. These two are next to each other. They add up to 180. And these two over here are 180 because they are next to each other. Okay? And then 8.6, if a parallelogram has one right angle, then it has 4 right angles. Okay, so this one's written a little differently. So our abbreviation for this one is if a parallelogram has one right angle, so you can shorten the word right to RT, angle, it has 4 right angles. Okay, that's an angle symbol and an S. Okay, so here's our example. Here's our drawing over here for this one. Okay, and what we're going to say for this example is in parallelogram JKLM, if in parallelogram JKLM, if angle J is a right angle, then angle K, angle L, and angle M are also right angles, and we can also mark that up here. Okay? Okay, we're going to do this example together. So example 1, so we're just looking at this middle section here, okay? In parallelogram ABCD, so they're making it a real-life example because it's a parallelogram holding up the basketball hoop. In parallelogram ABCD, suppose that measure of angle A is 55 degrees, measure of AB is 2.5 feet, and BC is 1 foot. Find each measure below and explain. So you have to show your reasoning here. This is where we're going to use those abbreviations. Okay, so the first thing we need to find is DC. I'm also going to mark up what I know. This angle is 55 degrees. That's 2.5 feet, and BC is 1 foot, okay? So we need to find DC. We know that DC is the same as AB. Okay, and the reasoning for that is opposite sides of parallelogram are congruent, so we have to write out that abbreviation. Okay, and now we can say that DC equals 2.5 by substitution. Okay. The same thing for measure of angle B. Let's look at measure of angle B over here. So the first thing we know is that measure of angle A plus measure of angle B equals 180 degrees. And we know that because we know that A and B are next to each other, which is called consecutive. So we are going to write consecutive angles in a parallelogram are supplementary, so that's our reasoning. Okay, and then we're going to say measure of angle, 55 plus measure of angle B equals 180, so that's substituting in for A. And then the last step is measure of angle B is going to be 125, and that's by subtracting 55 from each side. Okay, so that's our explanations. So whenever it tells you to explain, we have to write out our proofs like this. Okay, and the last one is measure of angle C, so that's down here, angle C. So we know that measure of angle C is equal to measure of angle A by a theorem we just learned, which is that opposite angles in a parallelogram are congruent. So that's our reasoning there. So therefore, measure of angle C is 55 by substitution. Okay, we have two more theorems today. So go ahead and title this theorems diagonals of a parallelogram and start writing these down, 8.7 and 8.8. Okay, 8.7 says if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, so we're going to abbreviate this, and we're going to write the abbreviation as diagonals of a parallelogram bisect each other. So there's not much abbreviating that one, but that's okay. So here's our drawing here. Here's our example, A, B, C, D, and that's P in the middle there. Okay, so it's our example is if A, B, C, D is a parallelogram, then AP is congruent to PC and DP is congruent to PB. Okay, so I'm going to mark that up. AP and PC, so AP and PC, so it cuts this one in half. Okay, and then DP and PB, so it cuts this diagonal in half as well. But that's a different congruence, okay? Those two are congruent to each other, but they might not be congruent to these two. So we have to put double dashes there, okay? And then 8.8, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. Okay, so that one's pretty crazy. Let's go ahead and abbreviate that. Diagonal separates a parallelogram into two congruent triangles. Okay, two congruent triangle. So you can write it like that. All right, so here's our example. Here we draw one diagonal, and we're going to say if ABCD is a parallelogram, then you can also say that triangle ABD is congruent to triangle CDB. Remember, order matters, okay? So ABD is congruent to CDB. Okay, make sure you understand that order matters as well there. All right, we have an example here. Example 2, if QRST, which is that quadrilateral drawn on the side, if it's a parallelogram, find the value of the indicated variable, explain. So we have to find the value of x, y, and z, and there's the parallelogram over there, and I already marked it up in the ways that we know that are given, okay? So just a couple things to clarify. This little angle is 95 degrees, this angle is 33 degrees. This angle down here, if you can't see it very well, it's 3z degrees, so it's 3 times z degrees. And then this 2y minus 5 is referring to this segment T to P. Okay, it's not an angle. And y plus 4 is referring to P to R segment. Okay, so it's not an angle either. So the first thing we're going to find is x. And we're going to write it, when it says explain, we need to give our reasoning in the form of a proof, just like we have been learning how to do. Okay, so x, if we're looking at x, where's x? X is over here. Oh yeah, the length of this side is 5x, okay? And you can't see it because of the light, but the length of this side is 27 from R to S. Sorry about the lighting, okay? So for our reasoning, we're going to say QT is congruent to RS. That's this side, QT and RS over there, okay? So that is because opposite sides of a parallelogram are congruent. That's our statement. It's our reasoning, I mean. Okay, so that means that QT equals RS. That's definition of congruence right there. So that means that 5x, which is QT, 5x, is the same, is equal to 27 on the other side. Okay, that's substitution. And then our answer is going to be x equals 5.4 . That's dividing by 5 on both sides. Okay. Next we need to find y. So let's go look at where y is. Y is right here, and in this segment over here, y plus 4 and 2y minus 5. Okay. So we know that TP, so this little one, T to P, is congruent to P to R. Okay, because that's a diagonal cut in half. Okay. That is because, just like the theorem that we just learned, diagonals of a parallelogram bisect each other. Okay, and then so we can say that TP equals PR. That's definition of congruence. And so then we can plug in what we know. We know that TP is 2y minus 5, and we know that PR is y plus 4. That's substitution. And then I'm going to get y equals, I'm not going to show the math here, but you're going to have to show the math in order to get this answer. Y equals 9, and that's by subtract y and add 5 to both sides. So all that math you can do on the side, and you'll get y equals 9. Okay, so that's your answer there. And then we need to find z. Okay, remember I told you this is 3z degrees. That's the answer there. Okay, so we need to find that z. So we know that you need to go figure this out. Look at this triangle on your own. TQS is congruent to RSQ. Okay, that is this triangle TQS and RSQ. So this triangle over here, this big triangle, and this big triangle on this side. Okay. Therefore, that's because diagonals separates a parallelogram into two congruent triangles. Okay? Then we can say that angle QST is congruent to angle SQR, because if the two triangles are congruent, then these corresponding angles are congruent, and that's called corresponding parts of congruent triangles are congruent. Remember that? CPCTC, which means that the measure of this angle is equal to the measure of this angle. So it's the same angles, but we just put it with an equal sign. That's definition of congruence. If they're congruent, then they're equal. And that means that this angle is 3z from the picture, and this angle over here is 33 degrees. That's substitution. Okay, and then when you solve this problem, when you divide both sides by 3, you get that z equals 11, and that's your answer there. Okay. All right, the last example I want to do is example 3. Determine the coordinates of the intersection of the diagonals of parallelogram FGHJ with the following vertices. Okay, so -2, 4, 3, 5, 2, -3, and -3, -4. So the first thing I'm going to do is I'm going to plot this, because it's much easier for me to understand if I can plot this. Okay, so the numbers are -2, 4, 3, 5, 2, -3, and -3, -4. Okay, luckily it's given that this is a parallelogram. Otherwise we couldn't assume it. We'd have to figure out some slopes. The slope of this one would have to be the same as the slope of this one, and then these two slopes would have to be the same. But we know, and then we could say it's a parallelogram, but they gave us that it's a parallelogram. So we're good to go for now. And then it says that we need to find the intersection of the diagonals, okay? So the point where they intersect. Now this is just a sketch, so I can't just use that as an eyeball, but I do know that the diagonals of a parallelogram bisect each other. So I'm going to write that out for myself. Diagonals of parallelogram bisect each other, which means that this diagonal has been cut in half, and this diagonal has been cut in half, which means that point is the midpoint of either diagonal. So actually, I just need to find one midpoint, the midpoint of either diagonal, and that's the answer. And then to check your work, you can find the midpoint of the other diagonal, and you'll see that it also will give you the same answer, okay? So let's do the midpoint of, let's just choose FH and GJ. So this one. Oh, sorry, let's do the one FH, okay, that diagonal. We're going to find the midpoint of FH. You could do GJ and you'd get the same answer, okay? So remember midpoint formula is the average of the x's and the average of the y's, okay, for FH, okay? So that is this diagonal here. So F is -2 and H is 2. Okay, and then F is 4. That's its y value, and H's y value is plus -3. Okay. So -2 plus 2 is 0, divided by 2 is 0, and 4 plus -3 is +1, divided by 2 is 1/2. Okay, so you can leave it like that, or you could write 0.5, it doesn't matter, but you're going to write that the diagonal, the coordinates of diagonal intersection. That's your answer. 0, 1/2, or 0.5, and then you can also find the midpoint of the other diagonal, and it will give you the same answer.